Okay, so looking at these from yesterday, okay, we had the NaOH, so sodium hydroxide was going to react with ammonium chloride. When that happens, we said it would be a double replacement reaction where the metals would switch. So we would have NH4OH and we would have NaCl. Okay, that was the prediction. But in the lab, what happened in that one?
It smelled like crap.
No, not crap, hopefully, but like Windex maybe, like really, really strong Windex. Okay? Like what, cat pee? Yes, it would have smelled like cat pee. Yeah, like a really old, bad litter box kind of thing. Yeah. Okay, reason for that is, if we smell something, what was produced? A gas. Are either of these gases? They were not. So, our prediction was wrong. That's fine. That happens sometimes. So what I'm going to do is give you a little bit of help on actually writing out the correct reaction, because in your analysis, that's one of the things you're asked to do. In the analysis, you are asked to write out in both formula and word form the reactions that occurred. Okay? So I need to see a formula reaction that is balanced and then written out in words for each reaction except 4 and 5. So, for this one here, we produced a gas. That gas was ammonia, which is why it smelled like cat pee. Okay? Because actually, cat pee contains compounds that are very much like ammonia. Okay? So, NH3 is a gas that was produced in there. 2 other things were also produced. Okay? In order to figure out what they are, I will show you where this came from. Okay, the NH3 came from here, right? So the ammonium ion broke up in this reaction. When that happens, effectively we take 3 of the hydrogens and the nitrogen off of this compound, and that leaves us instead with that. Okay, so now, if you can figure out what the rest of the reaction would look like, given that we've now removed the ammonia from there, okay, I think you can figure out the other 2 products. Okay, treat it like it's a double replacement reaction and go from there. Okay, for pair number 2, vinegar and baking soda, we said this was going to be a double replacement reaction, okay, and we were going to swap the metals, so we were going to get NaCH3COO, and we were going to get H2CO3. And what happened in that one? When you mix vinegar and baking soda, it fizzes, which means what's being produced? Gas. What gas? Carbon dioxide is actually being produced in that reaction. Okay, that's why you can suffocate a candle with it. So what we got here is CO2 and 2 other compounds. Right? 2 other compounds come from this. Now, the CO2 comes from here. The carbonate, the hydrogen carbonate ion, actually breaks up in this reaction. Okay? And so we lose 2 of these oxygens and the carbon, which leaves us with this. Right? We take away the carbon and 2 oxygens, we're left with a sodium, a hydrogen, and an oxygen, or sodium hydroxide, reacting with an acid. Remember, we said this is an ionic compound that really should be written like this. Right? Where this is the metal and this is the non-metal. Right? You got it reacting with that. You should be able to figure out what the other 2 products are from there. Okay, pair number 3. I don't think we had too much trouble with. I think that one went pretty much according to plan. Okay, what happened in that reaction?
White precipitate form.
Right, you got a white precipitate in that reaction, which can happen in a double replacement reaction. So I think probably the way you predicted that one would have gone okay. Okay, obviously we didn't have to predict pair 4 or pair 5. Pair number 6, very similar to pair number 3. What happened in that one? big, bright yellow precipitate. Yeah, right? Bright yellow precipitate, which again can happen in a double replacement reaction. So if you predict that one according to the rules of a double replacement reaction, you'll be fine for predicting the products correctly. And then for this one, okay, we have zinc reacting with hydrogen chloride, which is what kind of a reaction? Single replacement. Okay, and in a single replacement, the things that are alike switch places. So zinc is going to switch places with hydrogen, which kind of fits because when hydrogen's by itself, it's a what? Gas. It's a gas. Did you have evidence of a gas forming? Yeah, fizzing. In fact, I had one group where I lit a little stick on fire and I stuck it over the bubbling and fizzing, and it actually burns the hydrogen gas. It pops. The flame pops over top of the hydrogen gas. Okay, but yeah, hydrogen gas is produced in that one. So there, you're welcome. That's one of the products. You figure out what the other one is on that one. Okay. So the big thing here, guys, is that you need to make sure when you write out the reactions in the analysis. So let's talk about the analysis. Okay, question number 1 says, using words and formulae, write the chemical equation for each reaction that occurred in this activity except for pairs 4 and 5. Okay, so I should see a formula reaction and a word reaction for each of those pairs. Everybody follow on that? And I should see a balanced chemical reaction for each of those, right? So that formula one that you write out, the equation, okay, that needs to be balanced as well. People often forget to do question number 2, and I don't know why. It's right here. You forget it. Okay? 2 of the reactions produce precipitate. We just talked about that. Okay? Using the chemical equations you wrote and your solubility chart, identify the precipitates that formed in this lab. So you need to look at the products of those 2 reactions and figure out which of the products are soluble or not. Which one? Precipitates are not soluble, right? So you need to find out which of the products of those reactions is not soluble and write them down. Okay? This is me seeing if you can, kind of extrapolate something from your reactions. Okay, so figure out which of the products is not soluble. Those are your 2 answers. There's 2 things, okay, 2 precipitates. Okay, list them there in the analysis. Okay, questions on what you're doing for the analysis?
So are we erasing our predictions?
No, you can leave your predictions where they were, okay, and then write the full chemical reactions out in the analysis. Okay, right? Because in your file, right, you have one box that's for the predictions, and then you have an area below, right, in the analysis. Okay. Okay, so these are your predictions. Fill them in and leave them. It's okay. We know some of them are wrong. That's fine. They were predictions. Okay, and then down here in the okay, so I want pair 1, and I'm going to see a chemical reaction and then a word reaction. Pair 2, chemical reaction, word reaction. Same thing for all the others. I didn't even put pair 4 and 5 in there, so you don't have to do them. Okay, and then for question number 2, I just want, okay, in pair 3, the precipitate was this. In pair 6, the precipitate was this. Okay.
Going in words, formula, or both?
Doesn't matter. All right, then you got your conclusion after that. Remember that for your conclusion, you need to copy and paste your hypothesis and then explain using your data and your analysis whether you can accept or reject it. Okay? In this lab, we were looking for, okay, how do we know a chemical reaction has occurred? We said that, if this is a chemical reaction and things are mixed together, then the signs of reaction will be seen, and these are them. Okay, you need to talk about in your conclusion, in reaction 1, this sign was seen. In reaction 2, this sign was seen. Okay, these are all signs of a reaction. Therefore, a reaction occurred, and blah blah blah. Okay, so you need to have a good, thorough explanation that talks about what you saw and why that supports what Dalton said happens in a chemical reaction. Okay. All right, so the more stuff from this unit that you can work into the conclusion, the better. So some stuff from Dalton, some stuff about physical properties, some stuff about signs of a reaction, okay, things like that. Try and work all of those ideas into your conclusion. Okay, sources of error and evaluation. So 2 sources of error. Okay, looking for 2 sources of error here and ways to fix them. right? And remember, they can't be like human error, right? Like it was hard to smell it. Okay, find somebody better at smelling. I don't know, but okay, that's not a source of it. Okay, you need to come up with something else. All right, and once again, you do not need to do the class discussion questions. I had a bunch of emails about whether the class discussion questions need to be done on the last slide. No, they do not. Okay, we will go through those as a class when I hand back the lab. Okay, questions? All right, so I would suggest, since you still have quite a bit of time left, that you should start working on maybe writing out the chemical reactions for your lab. Okay, I don't think the Chromebooks are available. They are. Okay. So if you want a Chromebook, that's fine. If you want to just do it on paper, that's fine too. But remember, you're handing it in on Google Classroom, so okay, it's eventually going to have to end up in there.